All right, welcome back everybody. This is hashtag Corp Stat Chat. I apologize that it's been a little bit since my last video. I've been crazy around here, but I have 3 videos ready to go this week, so we're going to be in succession here. I'm going to try and get caught up with the content that we're learning about in class. So what we're starting to get into is this idea of histograms. So this is our next topic that we're going to be discussing, and histograms are just frequencies over intervals. So it's sort of like a bar graph, but a bar graph measures specific categories, different categories, but a histogram measures over an interval, and those intervals are called classes. So we're going to talk about that. We're going to walk through an example, and we're going to start off with a frequency table, because from a frequency table, we can derive a frequency histogram. From a frequency histogram, then we can arrive at a relative frequency histogram, a cumulative frequency ogive then is what our ultimate goal is. So we're going to be working through here, so I'm going to split these videos up into sort of 3 sort of different but similar topics, if that makes sense. Because they all tie into each other. So if you start out with our frequency table, we can continue on until we can arrive at all of our graphs that we're going to be working with. All right, so thanks for watching ahead of time. This is hashtag Corp Stat Chat, and let's begin with histograms.
All right, so let's start talking about some frequency table stuff and how we're going to fill out this table that's below. So what you should see on your screen right now is a frequency table that's set up with classes, boundaries, tallies, frequencies, and then we're going to get into, in another video, relative frequencies, and then cumulative frequencies, which will help us draw our relative frequency histograms and our cumulative frequency histograms, or called the ogive. Okay? Not the hand jive, the ogive. And we'll get to that in a later video. So let's first discuss how are we going to set up our classes. And remember what a histogram is. A histogram is just a representation of frequencies within classes. And classes are just intervals of numbers. So how we determine this is we got to determine the class width first. But before we can determine the class width, we need to know how many classes we're working with. And we're going to actually work with 5 classes here. 5 classes. And determine class width, we need to find the max, the x max, and the x min, and we're going to find the range between the highest and lowest number here, and we're going to divide it by 5. So let's do that now. So what we have here, if I look through my data set, I see that 47 is the highest number, and I'm looking through, and 2 is going to be our lowest number. So our minimum and our maximum, and what we're going to do is set up our class widths. So let's just label this as CW equals the range, so 47 minus 2 divided by the number of classes, which in this case is 5, right? So 47 minus 2 is 45, and then 45 divided by 5 is going to be 9. Now there's an issue here. If we would just do 9, what would happen is that our class widths are going to get thrown off a little bit. Our classes, when we start listing them down, and we're probably not going to include all of our data, especially the numbers in the top end of our data set. So what we do, no matter what, so this is a good example here, if I would have had 9.1, I'm going to round up to 10. Okay, but since I have 9, just 9, I'm still going to round up. So just sort of a side note, always round up. Okay, no matter what, we are always rounding up. So if I round up to 10, 10 is going to be our class width. And that's how many numbers are in each of our classes. Okay, so when we're setting these up, when we start with our classes, you'll notice that's a little different. We're not finding ranges of each one. So if you take the range, we're actually going to have a range of 9 in each class. But that's okay. We're going to use a class width of 10, so including 10 numbers. So our first class, we're going to start out with the lowest number. You always start out with your lowest number. It's no point in including 1 in this case, because 1's not even in the data set. So we're going to start with 2. Okay, now we need to include 10 numbers in our first class. So 2 to 11 is going to be our first class. 2 to 11. All right. Now, if you take the difference there, it would end up being 9, but that would be the range of that class. The class width includes 10 numbers. All right, so now we're going to move into our next class, and what we do is we increment by 1 to get to the next one. 11, 12, 12, 2. Okay, remember we're including 10 numbers, so this is 21. We're going to increase to 22 to 31. And we're going to go to 32 to 41, and so on. And if you look at all of our numbers real quick, you can see that they're going to fall into any of these classes that we have here. All right, so now what we need to do is actually include our boundaries for our classes. Now, since we all have whole numbers here, it's not really a big deal to figure out what class it goes into, but boundaries are important because boundaries here are going to end up making this histogram a histogram. Because if you have gaps between your bars, it's no longer a histogram, it is a bar graph. Okay, for histograms, we need our frequencies to be touching, our frequency bars to be touching, so we have a histogram. So our boundaries are just going to be plus 0.5 to the upper bound, and then minus 0.5 to the lower bound. So I drew this back, or wrote this backwards a little bit, but we're going to add 5 to our upper bound. We're going to subtract 0.5 from our lower bound, so we're going to end up with a boundary of 1.5 to 11.5. Okay, and then we do the same thing with the next one, 11.5 to 21.5. And what you should notice here is that the upper bound of class 1 and the lower bound of class 2 are the same, and that's perfect because that means that these bars are going to be touching then when we go to draw our histogram later on. And then we have 21.5 to 31.5. And then so on and so forth. So as I complete this column, we're talking about boundaries here. This is what we're going to end up graphing later on. The next part is sort of the most tedious part out of this whole thing, and that's actually just tallying up all of our numbers and to see which class they fall into. But once we do that, we'll be able to see that there's going to be a distribution shape, which we'll talk about later on in another video, which is going to be very important in making inferences based off of the data. Okay, so now that I have all my class boundaries set up, now all we do is start tallying up each one. And I'm fairly confident you know how to tally, so I'm just going to work my way across 13. You can always fast forward this part of the video just till I have all the data in here. 13 falls in between 12 and 21, or really my boundary here of 11.5 to 21.5. So I'm just going to put a tally. Okay, so I am done with that one. 47. It's going to come down here. We knew that 47 was our max, so that should fall into our highest category or our highest class. 10 is our next number, so that falls in between 2 and 11. 3, 16. And one thing that you might want to get into a good practice to do is start checking off these numbers. If you have a paper copy, check off the numbers so you know that you've used it, because especially when you're using a large data set, it gets really, really confusing, and especially if somebody walks in and starts talking to you, man, you want to hit them because you just lost count and you got to start all over to make sure that your tallies and frequencies are okay. So as we continue on, 20, check, 17, check. And you'll probably start to see a relative distribution shape here if you could just look at the tallies alone. So again, we're just tallying these off, finding which class they fall into, and we're basically counting up the frequencies of each one. And a frequency is just number of times something occurs. 25, 8, 21. And as you can tell, it's kind of hard for me to do this while I'm talking, but we will continue on. 17. What? 17. 14. Boom. And 6. All right, so now our last part of this video to talk about just frequencies. We're just going to add up these tallies. So 5, 6, 7, 8. We have 9, 1, 1, and 1. And when we start talking about distribution shapes, you're going to be able to better understand what this histogram is going to look like just from our frequencies. And we're going to talk about how to draw a histogram in the next video. So I know that this was a long video. It was sort of tedious, but it's a good habit to get into. A frequency table shows us a couple things. It shows us the classes that we have. okay, the intervals that we're taking these numbers by, the boundaries of each class, so where our numbers are going to fall, and we use boundaries because we want our histogram bars to touch. We're tallying up all of our numbers from our data set, and we are calculating our frequency. What we'll do in the next video is draw a histogram and then roll right into relative frequency, and knowing that we can use the same histogram drawing but using relative frequencies. All right, so this is Mr. Corb. Thanks for watching. This is #CorbStatChat, and I will see you next time. Peace.